Hi everyone, it is NeuroSciDM. I'm sorry for the lateness in producing a new video. I've been having some issues with focus and brain power lately. In this video, I would like to go over just a little bit of physics. In this case, what is temperature and how it relates to particle motion. Now, I originally made a version of this video for a job application at a nearby school system, and doing that was what made me decide to try and expand into doing science videos for neuroscience as a way of teaching and reviewing with the audience, and to develop some skills in content creation and make a portfolio for later applications. Um, I decided to redo this video with a little more animations and a little bit more of a script and some structure. And I hope you all enjoy it and hope you learn a little bit from it. So with that in mind, let's talk a little bit about how temperature and the motion of particles are related. Now, what is temperature exactly? Well, temperature is a measurement of the motion and energy of particles and molecules in a substance. And that substance could be a liquid like water, or a solid like a tree, or a gas like the air we breathe, or plasma. And we might do another video later on the different states of matter, how that I think about it. Well, anyway, to demonstrate this idea of temperature being a measurement of particle and molecule energy and motion, let's take a glass container of water sitting on a desk. And inside that water are particles that are moving around and colliding into each other and colliding against the air and the surface of the glass. And if we were to put a thermometer in that container and measure the temperature, we would see that the temperature is around room temperature. Now, for where I'm at in the United States, that is around 20 to 24 degrees Celsius, or somewhere between 68 and just a little more than 75 degrees Fahrenheit. Now, that may be different for where you live, depending on account of your elevation, the humidity, the distance from the equator, etc. But that's the idea. Now, what happens if we increase the temperature? Well, for that, let's say we put that container of water on a heat source like a hot plate, and we set the temperature on the hot plate to 60 degrees Celsius or 140 degrees Fahrenheit. What will happen is that heat from the hot plate will travel through the glass and into the water. And as the temperature rises, the water particles will become more energized and start to move faster and collide more often to match the temperature of the plate. Pretty straightforward. Now, what happens if we do the opposite and lower the temperature of the water? Well, let's take that same container, and instead of putting it on a hot plate, we instead put some ice cubes underneath it. Where will the heat go? Well, in this case, the heat from the water will travel down to the ice cubes to try and warm the ice cubes up. And if we stick a thermometer in the container, we'd get a measurement of about a little more than 1 degree Celsius or about 34 degrees Fahrenheit. This loss of heat, and therefore energy, will cause the water particles to slow down and not collide as often as they would at warmer temperatures. So again, pretty straightforward, pretty simple. Well, You may be asking at this point, why is it important to know how temperature and particle movement are related? Well, as a matter of fact, it's important for at least a couple of reasons. And first, in some later videos, we'll discuss how hot or how cold an environment is can affect how particles are connected to each other in a substance. Now, for example, think of it this way. You have a piece of chicken or some fish or some beef or goat or sheep, whatever meat you like to have. And you are cooking this meat either in the oven or on the stovetop. Well, when you cook the meat, the heat from the stovetop or the oven will start to break apart some of the proteins in that meat, and it'll make it easier for your stomach and intestines to digest it and turn it into energy for your body. Also, and this is very, very important, there are some functions your body needs to perform at an optimal range of temperatures. So being too hot, like when you run a fever while you're sick, and especially a dangerously high fever, or if you're too cold, like you are freezing from exposure, that can cause damage to your body because of what they can do to pieces of it. Kind of like with cooking the meat, a very high fever can start to break down certain proteins and whatnot, and it'll damage your muscles and other parts of your body. Same way, or similarly, if you're too cold, it'll cause things like blood vessels to restrict in your fingers and toes, and that is when you start getting damage like frostbite. But we'll discuss stuff like that a bit more when we cover some of the different functions of the body. Right now in these early videos, I want to focus more on the neuroscience, but because the human body is a combination of systems doing different jobs and working together to keep you healthy and alive, I would be remiss not to cover the other systems like the cardiovascular system and the digestive system and the respiratory system and how they and your nervous system work together for you to do what it is you do. Now, I hope you'll have a wonderful day and I hope you stay safe. See you at the next video. Bye bye.